The graduates, 5 on average earn 5,500, 15 on average earn 6,500, and so on. So these are the total earnings of these 5s. These are the total earnings of these 15. These are the total earnings of these 30, and these are the total salaries paid to all 100 graduates. So 805,000 divided by 100, so it is $8,050 a month. So the average salary for a graduate is $8,050. Now mode is the value which occurs most frequently, which salary is paid more frequently. So over here you see 30 is the highest number, so the mode is 7,500. And median, you don't have the median over here. Okay, so just two questions you're asking. Median and mode, okay. Can you tell me, if I ask you median, what will be the median? Approximately. What will be the median approximately? 5, 15, 30 is 50. 25, 20, and 5 is 50. Is even number data. 8,000. So 7,500 plus 8,500 divided by 2 is 8,000. Okay. So median is going to be about $8,000. Okay. Now, so the next question is find the variance and standard deviation. So if you recall, formula for variance is equal to so this is, you are looking at your population variance, okay? So over here you have calculated all those square deviations and divide by a number of graduates, okay? So from each x value you are going to be subtracting the mean value, which is 8,050. So 5,500 minus 8,050 squared multiplied by 5, 6,500 minus 8,050 is squared multiplied by 15, and you keep doing that and then divide the whole thing by 100. Or instead, so this is what, like we are looking at the dispersion around the mean. Okay. So this is how you do, but I'm showing you an easier formula. Okay. Where you don't need to calculate the deviation because it's very time consuming. Finding out the difference and then squaring it. What if this number is 8,050.69? So you did rounding over here. So now you have to punch in more numbers and there is going to be more rounding error. So this is the easier one. So what you do, you forget about this, you just calculate this column. You square each x value and multiply by frequency, okay? So this total over here. And then your variance is simply 6. It's like here I'm giving you the formula for the variance. Summation fx squared divided by n minus mu squared, okay? So just that, your variances. You are not calculating any deviations. You are not squaring any deviation. Okay? You just have this number divided by 100 minus your 8,050 squared. Okay? And that is 1,547,500. This will give you, like, you can try that. They both are going to be exactly same answer. So let's say this is your exercise for home, okay? Try this one and that answer is going to be exactly same as this. Now standard deviation is 1244. Coefficient of variation is 0.1545. We talked about all these things earlier, okay? So 0.1545. Now, the next question is, calculate the coefficient of variation and make an interpretation of that. I mean, interpretation is what? Relative to mean variability in monthly starting salaries of MBA graduates is 0.1545. Okay. So coefficient of variation is a measure of risk, measure of volatility, measure of variability in relation to the mean. So in relation to the mean, the variability is 0.1545. Now, I mean, how helpful this is? Is it more? Is it less? I cannot answer that. You have to compare with something. You are going to be comparing with some other company or something else. Okay. Then only you can say whether this variability is more or less. So, I mean, when you look at the standard deviation, when you look at the coefficient of variation, how do I know that this is good or not good? I mean, you have to compare with something else. And that's what we did when, if you recall, when I was looking at two stocks, I calculated mean, I calculated standard deviation, so now I can compare those two stocks. And then I calculate the coefficient of variation, so I can compare those two stocks. But if you just have information on one, you cannot say it is good or bad. Good against what? Or bad against what? Now, the next question is, assuming a normal distribution, within what range 95% of the salaries will fall? Approximately 95% of the values, if a distribution is normal, approximately 95% of the values will fall within two standard deviation of the mean. It's just an approximate number, it's not a precise exact number. Okay, it's just an approximate number. And approximately 100% of the values will fall within three standard deviation of the mean. So over here, if we assume that distribution is normal, your mean is 8050, approximately 95% of the values will fall within two standard deviation of the mean. So let me make a picture for you. So this is 8050. I'm looking at these two limits. This is mean. And the answer is 5562 to 10,538. 95% of the graduates will be earning anywhere between 5562 to 10,538 per month. Now let's say I have no idea. I have no idea that the distribution is normal or not normal. I don't know anything about the shape of the distribution. When you don't know anything about the shape of the distribution, then the best approximation you can get by using Chebyshev theorem. And what is Chebyshev theorem? I am drawing this picture not assuming that distribution is normal. I am not assuming that. It's just a picture, okay? At least this much percentage values will fall within Z standard deviation of the mean. At least this much percentage. So let's say this is 2. Suppose this is 2. 1 divided by 4 is 0.25. this will become 75%. So according to Chebyshev theorem, at least 75% of the salaries will fall within these two limits. Got it? Suppose this is 2. So at least 75% of the values will fall within 2 standard deviation of the mean. Now, what's the question over here? Assuming Chebyshev theorem, what is the probability that MBA graduate monthly salary will be within 5,100 to 11,000? This is 8,050. This is 5,100. This is 11,000. You can try anything. So, mean minus and that is what, 1244? I mean, Z or K are the same thing, okay? Whether I say Z or K is standard deviation. So 2.37. Now, so what is your conclusion? So according to Chebyshev theorem, 1 minus 1 over Z square, Z could be K, okay, Z or K, I mean, they're different notation for the same thing. So 1 minus 1 over Z square, all the values will fall within Z standard deviation of the mean. So when I look at this, I am getting 82.20. I am getting 82.20. So your answer is going to be that there is 82.20% probability that the average salary, the mean monthly salary is going to be between 5,100 to 11,000. There is 82.20% probability that the mean monthly salary is going to be between 5,100 to 11,000. So there is 82.20% probability that the mean monthly salary is going to be between 5,100 to 11,000. You guys are okay with that? Okay, let's go to the next. Random experiments counting rules and assigning probabilities, events and their probabilities, some basic relationship of probability, conditional probability based theorem, okay? %49% of the students in this class are male. I'm just throwing a number. What kind of probability is that? 49% of the students in this class are male. What kind of probability is that? They're marginal, conditional, joint. When I say 49% of the students in this class are male, what kind of probability is that? Like in my statement, I don't care whether you are CDP or whether you are MAF2001. I'm just saying of all the students in this class, 49% are male. It is unconditional. It is called marginal. It's a marginal probability. 20% of the students in this class are CDP and male. It's joint. Two events are happening at the same time. A student is male and also in CDP. It's a joint probability. Joint probability is probability of more than one event happening at the same time. Now, if a student is a female, what's the probability that she will write her CFA level 1 exam? It's conditional, okay? It's conditioned upon then your gender. Okay. So these are the three types of probabilities, okay? But before, I just talked about that. Okay. Let's just quickly look at what we are talking about over here. Now, I did so much study, I am 200% confident that I'm going to get an A+. Does this statement technically make any sense? I mean, by saying 200%, you are just emphasizing. But there is no such thing as 200%. Maximum is 100%. So, as far as total probability is concerned, it is going to be 100%. Probability of getting an A is less than 80%. Probability of not getting an A is 20%. Total is 100%. I'm looking at this. There are only two outcomes, A or not A. Not A could be anything. If probability of A is 80%, that means probability of not A is 20%. It cannot be anything else. And what's the total? Total is 100%. So, and if the probability of getting an A is 100%, probability of not getting A is 0. Total probability is going to be 100% of all the outcomes of any experiment. Okay, the total probability is going to be 100%. Okay. So here I'm just talking about that. Okay. So 80% probability of getting an A, that means 20% probability of not getting an A. Now here we are just talking about different experiments, okay? Toss a coin, head and tail, inspect a part, effective, non-effective, conduct a sales call, purchase, no purchase, roll a die. I mean, you know all this stuff, okay? Now, I'm just going to ignore that. You can read it yourself. Tell me one thing. Maybe I should. Investment gain or loss in 3 months. So you are going to be investing in these two stocks, Markley Iron and Collins Mining. Okay. So over here you can be making 10 million. What is that? 10,000, 5,000, 0, and lose 20,000. Make 8,000 and lose 2,000. You are investing in both. The outcomes are independent over here. This has nothing to do with this. Now, can you tell me, when I'm investing in both of them, how many possible outcomes I can have? And that you can see over here. Markley Isle, you can have a gain of 10, gain of 5, gain of 0, and loss of 20. Markley Isle, you have a gain of 10. How about Collins? You could be making 8 or you could be losing 2. So when you look at the number of outcomes, total outcomes, okay, marking or joint outcomes, this and this, they are 8, which is simply 4 times 2. So these are all the possibilities. Okay. These are all the possibilities which are 8 outcomes in total. Okay. Now, assigning probabilities, classical method. Assigning probability based on the assumption of equal likely outcomes, relative frequency assigning probability based on experimentation, or historical data subjective method assigning probability based on judgment. Now, let's look at each one of them. Classical method. If an experiment has n possible outcomes, the classical method will assign a probability 1 over n to each outcome. Roll a die, sample space. Die has 6 sides, so 1, 2, 3, 4, 5, 6. Each sample point has a 1/6 chance of occurring. Okay. Now, toss a coin. There is head and tail. So there are 2 possible outcomes: getting a head or getting a tail. Tell me, getting a head, when you toss a coin, these 2 outcomes, head or tail, are they mutually exclusive? Yes or no? Are they mutually exclusive?
Yeah.
There is nothing in common. Are they dependent or independent? Are they dependent or independent?
Independent.
Independent.
Like the result. Each result.
Occurrence of head. Doesn't it depend upon non-occurrence of tail?
Oh.
It can only happen if tail doesn't happen. There is dependency. So they are mutually exclusive, but they are dependent. Same thing goes over here, rolling a die. Okay. These are mutually exclusive outcomes. Like 1 and 2 has nothing in common. It's number 1, number 2. Okay. Are they dependent or independent? They are dependent. 1 can only happen if 2, 3, 4, 5, 6 doesn't happen. Don't happen. Now, relative frequency method. Over here, what you do, you look at the historical data. Okay, so here I'm just giving you an example. Okay, number of polishers rented, 0, 1, 2, 3, 4, and this is your historical data. Number of days, of all the days, 4 days you rented 0, 6 days you rented this much, 18 days you rented so much, 10 days you rented so much, and 2 days you rented so much. You collected data for the last 40 days. So what are the probabilities? 4 divided by 40. 6 divided by 40, 18 divided by 40. So these are going to be your probabilities using relative frequency method. Okay. Subjective method. Okay. Now this depends upon your own beliefs. This depends upon what you're thinking. Okay. How much weight you're assigning to each event. If I ask you a question, can you tell me what's the probability that within a month, oil price will go up to $150 per barrel? I'm asking a question. Can you tell me what is the probability that within a month, oil price will hit $150 a barrel? Right now it is around $100. It went up to $110 or $15. Okay, will hit $150 a barrel. What's the probability? Then just give any answer. What you think?
It's always going to change for each person. Everyone will have their own answer.
That's what I'm asking. So give me the answer. What do you think?
In 1 month? Is that
Yeah, within a month. 20%?
Like 10% chance.
10%? Yeah. 100%? See over here, all the answers are different. This is what happened when you're using subjective method. We are thinking, we are giving weights to different things, and we are coming to this subjective estimate. Okay. So in case of this method, everyone is going to give a different answer. And that's right, there is nothing wrong with that. Okay. We are just estimating, okay, based upon our subjective views, okay. I'm just passing, moving on because there is nothing, and you have done all this. Can you tell me, so one event is getting ahead, toss a coin, get ahead. What's the complement of that?
Toss a coin, get tails?
10. Okay, that's the complement. Total is 100%. Okay. So that's what I meant by complement, okay? Okay. So what I'll do now is, we'll just do an example. We'll do an example now. Okay. And in that example, I'm going to explain you. So you have this with you. You can open your email, right? Frankie Fang selected a sample of males and female students from Ellesmere University BBA program. In his sample, females were 25% as much as males. 25% as much as males.
So 105? Sorry, 104.
25% as much as males. So if males are 100, females are 25, right? If males are 100, females are 25. If the total number of students are 100, then how many females and how many males?
20 females, 80 males.
That's right. Thanks a lot. Okay. So Frankie Franks select a sample of males and female students from Ellesmere University BBA program. In his sample, females were 25% as much as males. He also found that of males selected, 90% had passed a course, and of the females selected, 95% had passed. Now, so when you look at the solution, sorry, you just answered me that 80% of the total students, 80% are males and 20% are females. Also in the question it says, he also found that of the males selected, 90% had passed a course. Of this 80%, 90% had passed the course. Let's think about this as not probabilities, think about this as numbers. So this is 80, this is 20, this is 9, and this is 91. Forget about probabilities. Of 80 students, 90% passed the course. So how much is that? 72. 72 students passed the course. Of 20 students, 95% passed the course, which is 19. So you have the numbers, but if you divide them by 100, okay, you have probabilities. Okay. So 72% and 19%. Now the total over here is 80%. If this is 72, percent, this has to be 8%. Or total over here is 80. If 72 students pass, that means 80 students fail. Total over here is 80. If 72 pass, that means 8 fail. So I have these two numbers, I have this number. Now this is just the difference. 80% minus 72%, 20% minus 19%, so I have that. And then I'm adding these. Now the first question is, if you select a student at random, what is the probability that he, she has passed the course? We don't care about the gender. We don't care about the gender. We just like to know what's the probability that the student has passed the course. And the answer is probability of passing the course is 91%. Next one. He is a male and failed the course. Poor male. Look at the big smile on girls' faces. I mean, you are all buddies, okay? You should be sympathetic, caring to each other, okay? Not smiling, okay? Look. Okay. So over here, what's the question? Male and fail the course. So it's a joint probability. Both things need to happen. Okay. Now over here, male fail the course. 8%. I am going to pick a student at random. What is the probability that this person is male and fail the course? And the answer is 8%. Third one is female and pass the course. I am going to pick up the person random. What's the probability that the student is a female and pass the course? And that is going to be 19%. Joint probabilities when two events happen together. Two or more events, okay, happen together, okay. So we got the answers. Now part C. What is the probability that if a student passes, that the student is a male? Can you tell me what kind of probability is this? You know that the person has passed the course. What's the probability that this person is a male? Now, what's the probability of passing the course? Is 91%. Or look in terms of numbers, like how many, so if I convert this into numbers, how many students pass the course? 91, right? How many of these were male? 72. 72 were male. Okay. 91 passed the course, 72 were male. Who are these 72? These 72 are male who passed the course. So what I'm doing over here is, this 72 is what? Is it marginal, conditional, joint? What it is? It is joint. It is not probability of passing the course. It is not probability of being male. It is probability of being male and passing the course. So if I ask you, a person is you know that the student has passed the course, what's the probability that this person is a male? It is going to be this divided by that. This is a joint probability and this is the marginal probability. So you see over here, pass. So this is how you are going to denote, okay? If the person is a male, if the person has passed the course, what's the probability that that person is a male? Put down the joint probability of male and passing over here and divide by probability of passing. 0.72 divided by 0.91 is 0.7912. You guys are okay? What is the probability that a student is a male? He failed the course. Now we know that the person is male. Person is male, failed the course. There are 80 males. Of that, 8 failed the course. This is the probability of male and failing the course. This is the probability of being a male. So, find, so, I'm not doing the right one. You're failing. Okay. So, failing and male divided by male. So, 0.08 divided by 0.80 is 10%. So, there is, if a person is a male, there is 10% chance that this person will fail the course. What is the probability if 3 students selected random, they are all males and pass the course? Like, does one person generate more than the other person generate? Does your passing depend upon the other person passing? There is independence. There is independence. Okay. So, what's the probability that a person is a male and pass the course is 0.72. If you pick a person at random, what is the probability that this person is a male and pass the course? Is 0.72. But if you pick 3 people, okay, it is simply going to be 0.72 times 0.72 times 0.72. Look at this.